All right, we're back. We're on page 2 of notes 2 of Calc AB, and we're talking about the chain rule, which is a new, exciting way of finding derivatives because it will save us a lot of time. The thing you have to get used to is identifying compositions, which is kind of funny because you probably intuitively recognize them. They're kind of the functions where, like, given an x value and you plug it in, first you do one thing to it, get an answer, then you do another thing to that answer, then maybe you do another thing to that answer. Like, you can kind of think of them as reversing the order of operations to, like, figure it out. So I'm going to show you two different ways, I think, of finding these derivatives. So the first way that I'm going to talk about it is the way that I sort of do it. It's very hard to really convey it, but I'm going to give it a shot. All right, so I see two functions, right? And so the functions that I see are cosine of something, and then another thing is just 4x, right? So I want to take the derivative of the biggest outermost function first. So here's how I think of it. dy dx is going to be, what is the derivative of cosine of something? The derivative of cosine of something is negative sine of that thing. But now by the chain rule, times the derivative of that thing. So times 4. So I'm going to say that dy dx is negative 4 sine of 4x. I find that for whatever reason, when you're doing this for the first time, trig functions are like a really good way to do it. So the derivative of cosine of something is negative sine of that thing, and then times the derivative of that thing. That's what we have. Now, the alternative way of thinking of this is that you could say that y is equal to the cosine of u is equal to 4x. So dy dx is going to be dy du times du dx. Okay, so now I need to find dy du and du dx. Also, I'm going to move this over a little bit so that I'm not infringing upon any other problem's rights. Okay, so the derivative of y with respect to u. So dy dx is going to be, the derivative of cosine of u is negative sine of u. So in the previous way of doing it, I said it was the negative sign of that thing. The derivative of cosine of something is negative sine of that thing. Now I'm saying the derivative of cosine of u is negative sine of u. It's negative sine of that thing times du dx, the derivative of that thing. So if if u is equal to 4x, then du dx is just 4 times 4. Now the weird thing about this way of taking the derivative, which I'm going to move again, and eventually I'll get this right. The weird part about this is that our final answer isn't our final answer because we still have u's in it and we don't want that, right? So sine of u is actually sine of 4x. So here we would have dy dx is negative 4 sine of 4x. So these, you'll pick up speed, obviously. So I'm gonna like try to highlight as I went through. So we got that, and then here it was dy du, that comes from here, and then we found negative sine of u, and then finally you do your substitutions. So that's how you're gonna do it. So I prefer to just think of it in a very general way, but I find initially a lot of people like to break it down, like really break it down. So I'm gonna keep going and we'll see how this goes. So the derivative of y, so dy dx. All right, what's the derivative? I see two functions. And so it's going to get harder to highlight as I see more functions. But right now I see two functions. I see secant of something, and then what's that thing? That thing is x to the 4th, right? What's the derivative of secant of something? The derivative of secant of something is secant of that thing, tan of that thing, and then times the derivative of that thing. Well, that thing is x to the 4th. The derivative of x to the 4th is 4x cubed. So I would say that dy dx is 4x cubed secant of x to the 4th tangent of x to the 4th. Okay, so you're going to get better at these. the key thing is you got to get used to looking at a composition and like decomposing it sort of. So here, an alternative approach would be to say y equals the secant of u, and then u is equal to, I feel like my marker is bigger than it was, but I guess it's not. I think I'm just zoomed in more. Okay, so u is equal to x to the fourth. So if you do y of u, you just get secant of x to the fourth. Like you need to be able to do the composition and get back to the original, otherwise this isn't working. So dy dx is going to be dy du, the derivative of y with respect to u, times du dx. And now it's just fill in the blanks, right? So I have to find the derivative. So dy dx, the derivative of secant of something is secant of that thing, tan of that thing, and then times du dx is 4x cubed. So let's go through and highlight, right? So we said y was equal to secant of u. So we needed to find dy du, and dy du is this. And then we said u is equal to x to the fourth. We needed dy du, and then that was this. Now we wouldn't leave our answer like that though, because this answer has u's in it and we don't want that. So we go that one last step and we say dy dx is the secant of x to the fourth, the tangent of x to the fourth, and then times 4x cubed. I'm realizing I should have put 4x cubed first. I forgot. So, but you can see we're getting the same answer either way. It doesn't make a difference which approach you use. So I think what I'm gonna do is I'll do one more in this video, and then I'll come back in another. So we got this same answer both ways here, same answer both ways. The first way is a lot faster. The second way is going to help you out when you're in a bind. So you need to know it. Like you can't avoid knowing this like differential operator notation for the chain rule. Like you're going to have to use it. It's especially good when we get to problems that involve like units and rates of change, like where we know like miles per hour and then hours per gallon. So you can get miles per gallon out of that and things like that. But I primarily find the derivative using sort of the more intuitive sense. So look what I'm doing here. I'm rewriting this like this. I'm doing that because trig functions have, because of the place you put the exponent, it's a little harder to see the composition when it's like sine squared, sine cubed, but you can always rewrite it. Eventually when you do enough, you're not going to rewrite it, but you can always rewrite it this way. So you actually have something squared is, I wish I could do that in one shot. Something squared is your first function. And then inside of something squared, you have sine of something. All right, so when I take the derivative of this, I say the derivative of something squared is 2 times that thing. So 2 times that thing, which is sine of x, times the derivative of that thing. The derivative of sine of x is cosine of x. And then I would just be done, right? So dy dx is 2 sine x cosine x, which if you remember the 14 formulas from math analysis, that's the sine of 2x. Like you could say that's sine of 2x. You don't need to though, that's not really the point of this. So let's see if we can like follow through what happened here. So it's the derivative of something squared is 2 times that thing, and then times the derivative of that thing. And so in my mind, I'll just keep saying, you know, so it's 2 times, so the derivative of something squared is 2 times that thing times the derivative of that thing. That thing is sine of x. The derivative of sine of x is cosine of x. I'll just keep going. If it was, you know, if it had been sine of x cubed, then it would have been 2 times sine of x cubed times the derivative of sine of something is cosine of that thing. So that thing is x cubed, so I'd need to multiply by 3x squared. And you just keep going until you've taken the derivative of every function that originally was in the problem. So let me do this the other way. So if y is equal to u squared, u is equal to sine of x. So dy dx will be dy du times du dx. All right, so dy dx will be the derivative of y with respect to u is 2u times the derivative of u with respect to x is cosine of x. But then you don't leave your answer that way because u is equal to sine of x. So your final answer here, dy dx, is 2 sine x cosine x. So you get the same answer regardless of which way you do it. I think it's a really good idea. So here was this. I think it's a really good idea to become really, really capable with both methods, actually. Right? There's no reason not to know both of them. So this is the beginning of the chain rule. So I'm going to be back in the next video to do more of this. Looks like this page might take us a while. So I will see you in the next video.